Okay, start. Yes. Okay, afternoon. My name is Yujia Zhai. I'm from University of Hertfordshire. I'm a lecturer in the engineering department. So um, I know here teaching in the university here. Do we have? Okay, yeah. um, the so today I'm talking about the randomization and automation on coursework design for a engineering course. My background is engineering, electrical engineering. So the program language I using that will be C or a similar language. Most of them they are closer to the hardware. But I got a new role in the university called IET accreditation officer. You know, any program in the university need to be recognized by a professional body. So in UK here, that will be the Institute of Engineering and Technology. So working as this role, I need to process a lot of files, folders, maybe 40 folders, a lot of files. And then I realized there's a need for me to learn a language which is processing the text, because text is related to the folder, and then text also related to the file name or something. So there was one day I found just outside my office, and then there is a book free to collect, and that is Perl, learning Perl. I remember that. So I think that's a kind of fate. So I start to learn Perl. So I quite enjoy it. And then in addition to learning Perl, I also learn Raku. And I just try because I'm really a beginner in this field. But later I found that not only manage the folder, it's very useful for me to extend this knowledge to design a coursework. Because in university, we are trying to talk about the randomize the student coursework. Yeah, so later, and so that is some background about myself and then why I need to do this project. And then thank you, Lee, and then the author, I forgot the name, the Pearl Marvin, the website. Yeah, I learned a lot from the website. Okay, so today this is the outline. I will talk about why I need to do this, and then what is the challenge, and then what is the method I have, and then I will give a demo. And then after that, and then I just put something about discussion, and then maybe I can get some suggestion from you. So first is the motivation is here I will talk about the module and program. This module is not the Perl module. It's a unit in the program specification. So student they got each semester they got 4 modules to learn. So module level, if we design a coursework with a randomized parameter, each student will do the different coursework. So it's easy for us to keep the academic integrity. So on program level, as I said, as an IT accreditation officer, some academics from other university, when they evaluate our program, there's one issue they raised is if this is a simulation-based coursework, every student using the same parameter, they can copy each other. How you can justify that this is your program running while? Yeah, so we need to do this. So this is from module level and program level, and then we have to think about the randomization. And then what we expect is, if we think this is what we should do, and what our expectation is from the student side, we want the coursework. This is kind of assessment are fair enough for every student. Yeah, because it's better to let them do the different coursework on some level, maybe not completely. And then from the module leader is, if we design the coursework with the random parameters, how we will do the marking. Yeah. So even just times the table. If it's a times table is 10 times 10, so everybody can calculate. No need to provide a solution. But if we randomize the questions like 10 times 10 or 100 times 100, this kind of times table cannot be directly you can calculate it. It's very difficult. So considering if each question is each assignment to a student, I need to know the answer before I mark it. Otherwise, I think it's not in practice not possible. Yeah. So the challenge is when I process the IT accreditation process, this is what they require for the documents on the assessment. So the first is the coursework briefing, and the second is the coursework task, and then the coursework examining solution, student submission, and then actually provide the feedback to each student. So the first one, coursework briefing, that is easy because coursework briefing normally talk about for this coursework, how many percentage of overall mark it is, yeah? When it should be submitted, and then what is the learning outcome this coursework will cover. So every student will got the same, no problem, yeah. But when we talk about in coursework design, the second, yeah. So if each student got a different task, and then we also need to provide the solution. So this is for every student. This is also for every student. Should be different. So that is the challenging. And then I need to deal with. So the method, I'm a guy from the engineering background, so I will always think about the definition on the manufacturing. So when we talk about manufacturing, is we have the batch production. So what is the batch production? Is efficiently manufacturing the customized product for customer. So if we consider education is also an industry, what we are going to do is we need to efficiently produce the customized coursework for students. So that is the how to do the mapping from the different field. So the questions, and then if for simple, that will be something like this. So from this example I played with my son, I identified to design this, I need to have a control loop, which is working as an organizer, and then we have a calculator and a monitor. Calculator here I'm using the Octave, which is a software similar with Massification. Okay, so for monitor, which is like this monitor is for to visualize the data. But consider report, that will be LaTex. Now I have the questions for my mechatronics coursework, and then normally this is the typical three kind of questions: modeling, yeah, two modeling questions, and then one design, controller design questions. So what I using, or what I expecting student produce, that will be the text and figure, text figure, or text and figure. So which is different from those numbers I produce. So in that case, what I'm trying to thinking is for engineering application, I also need to identify in my implementation, what is the data manager, what is the data producer, and then what is the presenter. So in this case, I'm using Perl overall manage all the different software. I using Perl as a program language to program the other language, which is Octave and LaTeX. So LaTeX here will finally using to produce the PDF file. So here is the structure of it. And then for my personal opinion, I think it's better we using all offline automation because most of them are open source based, and then quite useful. So in this case, I will give you an example about what I have done. Yeah. So in this case, I will open, this is a term. Yeah. And I will go to and then here is the demo. So first I will go to here, and then I have this file, which is the Perl I developed. And then I will finally output all these randomized exam paper, and then with example solution here. So here I have a Perl, and then exam. Sorry, what's the name? Exam auto. Okay, so Perl, exam auto. Okay, so once I run this, you see in real time, and then you will see some figure, which is generated figure using Octave. And then I have programmed another format for the report. So in this case, and you will see automatically this system will generate the student file. So this file is something like, yeah, if I open this demo, the basic idea is a student got a kind of a kind of student information, name, student ID number, and then this is email address. Due to the GDPR policy, I cannot using the real student name, but a similar format like this. So once I create this exam, and then you will see here, for example, I will say HR, and then from this file, I will see for Asia, I got two files. Yeah. So one is only about the task, and the other is a task with the solution. So if I open these two files, yeah. Okay. So that is the file with randomized parameter about MCK systems. And then this is this one is with the solution. This is without solution. If we go to the student questions, sorry, it should be this one. Yeah. So if we go to the student questions, and then we can switch the LaTeX, there's a switch. If we switch off, which means we only provide the student's questions about the MCK system. MCK here is randomized. But if we switch on the solution, and then at the same time, same format, but it provide the solution. So this means I give this task to the student, and then I give the external moderator this file. Yeah, so this is automatically designed for student, for external moderator. Yeah, and then after that, when I do the marking, I will assume this is, for example, if this is a student submission, this is my example solution. I open these two files. Open these two files, and then I can produce an Excel file. So this Excel file is something like, yeah, so that will be Excel file. So for each question, so what will be my mark? Yeah. So according to IET, the recommendation is when you give the mark, we have to provide the feedback. So the feedback is given in this way. I will mapping this feedback into the comments. So I will generate the comments using so that is the second project I use is Raku. So what I did is I first I will open this example student submission, and this is my solution, and then I will give them the marking. This marking is subjective. Because the design question, it must be subjective marking. Yeah, I cannot use a mechanical marking. So in this case, and what I'm going to do is, you see, I assume this is a student submission. So this is a fixed submission, something like that. So this is also from Asia. Yeah. So after that, and then I will put all the output file here. Yeah. So what I'm going to do is, so I will give it demo, this auto marking, and okay, so I will run Raku auto again, yeah, and then I will go to the output file folder, which is this one. So each file and the Excel file result will be mapped here, and then from the output we can see here is something like this. So for example, question one, what will be the mark? Is a mark. This mark is in band marginal pass. So this is the total mark of it. And then this following is the feedback is also automatically generated. Using ChatGPT, of course. And then in this case, and then if a student need to have very specific feedback, and then I'll put a note here, you can approach me. Yeah. So that's some demo I have. So if we back to the yeah okay, so now we come to the conclusion. So I think in this case, and then for the automation on the coursework include the marking, I have it done. And then because the coursework design, it comes with the solution. So for model leader, it can easily do the marking. And then once they finish the marking, and then all the feedback could be given to the student. And then the advantage, yes, include efficiency, productivity, quality, because it's all come from the same template, so it's okay. Cost reduction, generate the coursework, maybe 2 seconds for each student. And then it could be extended to other module, okay? But the first code, this tool is about 2,050 lines. So which initial cost could be long, could be high, and then people are carrier, so I can do it, maybe my colleague cannot do it. And then complex implementation, so this is software using Linux, Bash, Perl, Octave, and LaTex. And then security risk is if the student got all the source code, if I make it open, and then difficult to manage. Yeah, and then ethics and social concern, I think sometimes I don't feel the soul of from this coursework design. But I think if the randomization is necessary, and then this is a necessary evil, so it is something we can improve this project. Yeah. Yeah. Okay. So do the marking, and then cost effect. I believe if we want the randomization design in the coursework, so automation is necessary. So this is a cost effect. Yeah. This is some tool I use, and then thank you. Yeah. A little bit rough. Sorry about it. Yeah. Any question? The numerical calculation, it depends on what kind of question it is. You see that if given the MCK system, you will only ask the student to calculate the natural frequency. So that is one equation, right? But you know, the question 1, 2 is about modeling, 3 is about the design, controller design. Controller design, so for sure we need to apply some design rule. So there are some tuning process. So this tuning process, and then for me, maybe I can do it in the programming. But if a student, maybe they need to do it trial and error by hand, manually. So in that case, and then from my side, I can have such kind of a solution. But when the student, when they do, and then they need to do is by hand. And so how I say is analysis questions or design question is possible. But like I said, for design question, it must mark the, according to my opinion. Yeah, please. Yeah. No, no, that's. I know because in our university we're using the Canvas. You know, Canvas is based on a Ruby that programming environment, and then it's provided by Instructable. I think it's by a company. Moodle is open source. Yeah, it's kind of good. But for me, if I'm a university staff, I prefer offline automation. So I just mentioned, because in this case, when I design anything, if I do anything, it doesn't depend on any company. It doesn't depend on any website. I think from my personal development is more sustainable. So if I design the whole process in for example, Canvas, so what if the university change, or I want to change it into Moodle? So what I've done, and then that will all go in mind. Yeah, yeah, but not the simulation. Yeah, because engineering, for example, are using the Octave or MATLAB, and then from my knowledge, I don't know any company when they design this e-learning system online, they have interface with MATLAB. They have C programming, yes, but if it's MATLAB, and then, for example, the numerical simulation, I don't know. But I feel it's a kind of challenging. pdfunite, pdfunite, because it's according to the policy, all the file for accreditation need to be PDF. So when we put this online, yeah, we put this online, but not in the HTML or fill some kind of form. We must provide this PDF file to the student. Yeah. Okay. Yeah. Some people saying LaTex. This X doesn't pronounce anything. Yeah. the the no, I can show you what I have done. For example, how to say, I can show you what this file look like. Yeah. So what I'm doing is for this code, and then there is one code I'm using is to produce the LaTeX. Yeah. So here you see this program here, this function is once I got this result, and then I have a print LaTeX file. So all these things is the LaTeX grammar, and then I printed is a plain LaTeX file. So, but it's using the simulation result I have from Octave. So Octave data will be imported by here is Raku, and then put it into the text. For example, if in Octave your calculation is pi 3.14, so this number will be put into here is 3. Is not pi, is 3.14. So the same is other simulation result. It's all here, and then it's generated, and then I call a shell command combine. After this compiling, and then the output that will be the PDF file. So I change this PDF output into some student name ID, and then I can give it to them. So that's it, the whole thing. Yeah. 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 Thank you. Yeah.